So it is the end of Unit 4, and we are preparing to take the end of unit assessment, and this review should help you do that. So the first question, Betsy has a recipe for chocolate chip cookies. Yummy! She uses 3.5 cups of those chocolate chips to make 4 dozen chocolate chip cookies. Stan will follow the same recipe. He will make C dozen chocolate chip cookies using H cups of chocolate chips. Which of these equations represents the relationship between C and H? Okay, so the first thing we have here is that she uses 3.5 cups of chips, chocolate chips, of course, to make 4 dozen cookies. So the easiest thing is typically to set up a ratio, but before we do that, we want to make sure that we understand what C and H represent. So I'm going to write a couple of let statements here. I'm going to say let C equal the number of dozen cookies. And obviously, you know those are chocolate chip cookies, unless you want them to be some other kind. But in this one, they are not. The next one is let H equal number of cups of chocolate chips. Okay, so the next thing, we want to set up that ratio. So I would say the best thing probably is we want it per dozen is the easiest thing to understand. So what I mean by that is that we have H, the number of cups of cookies, cups of chips per dozen. So H, again, is the number of cups of chocolate chips. So it's 3.5. I'm going to automatically just change 3.5 to its improper fraction. 2 times 3 is 6, plus 1 is 7 over 2. And C is the number of dozen, and in the example they gave us, that was 4. So this, of course, means that I'm a division problem. So I'm going to bring that down here to do. So it would be 7 halves divided by 4 over 1. Oh, Math Macarena, woohoo! So that means I'm going to keep the first, flip the second, then we multiply, keep the top with the top, 7 times 1 is 7, and the bottom with the bottom, 2 times 4 is 8. So that tells us that it's 7/8 cups of chips per 1 dozen cookies. So this is helpful. However, that hasn't written our equation for us yet. So it's important to note that each of these equations has C, what C equals. And C is the number of dozens of cookies. So I know if it's 7/8 cups of chips per 1 dozen, and if I think about that, if I made 2 dozen, I would have to multiply my 7/8 times 2. If I made 3 dozen, I'd multiply my 7/8 times 3, and so on and so on. So that means I know that I'm always multiplying my 7/8 times the number of dozen, and that, of course, would, the number of dozen cookies, and that, of course, would be my C. So that means I have 7/8 C, or 7/8 times C, equals H. I could have put the equals H at the end, but it's always nice and it's cleaner to look at if the single variable starts the equation. Now, I still am not done, because if you look at each of these, C is alone, and in my equation that I wrote, H is alone. So in order to change that, I know I need to get C by itself. So that means that I would divide, technically, both sides by 7/8. That's how that 7/8 goes away from that side. I know I'm kind of running out of room here, but I don't want to stop what I'm doing. I'm actually really not. So these two cancel, because 7/8 divided by 7/8 is 1. Remember, any number divided by itself is 1, so that's why that's the case. And then I bring this over here, and I treat this like any other division of a fraction. So it would be h divided by 7/8. I keep the first, flip the second, then I multiply, so that equals 8/7 h. So in writing my final equation that has that c first, it would be c equals 8/7 h. So that is the final answer. Do I have that here? Yes, I do. It's choice C. Next problem. Paul measures his height to be 65 inches. His actual height is 64 inches. Which of these is closest to the percent error for Paul's measurement of his actual height? So I know when I'm finding percent error, the proportion for that is always error over actual, and that equals x over 100, because x really, it should be percent. Don't forget that's really percent. I know that's a funny looking percent, but anyway, percent over 100. Sorry about that. I actually put the x there because I know in this case the percent is what I don't know. So the error. So that means the difference between the measured height and the actual height. So that would be 65 minus 64, and that equals 1 inch. So that's my error. So using my proportion, I'm going to put 1 over. The actual is 64, and that equals x over 100. And then when I cross multiply, I have 64x, or 64 times x, equals 1 times 100. I know that 1 times 100 is 100, so I'm just going to keep going. 64x equals 100. I am still solving for x, so I'm going to divide both sides by, what is the x multiplied by? 64. So divide both sides by 64. These cancel. I'm left with x equaling, I use my calculator, and of course I get 1.5625. And now this is kind of a tricky place because, well, not really, you should know how to round, but in case you forgot, that could confuse you, because if you see, I've got two answers here that are awfully close to this. They're both in the tenths place, which means I'm rounding to where the 5 is. Means I look at the 6. The 6 is greater than or equal to 5. It is greater than 5, so that means I round up. So therefore, my 5 becomes a 6. So it's 1.6, and of course that's 1.6%. My answer is C. And look at that, I made a typo here. That should not be C, that should be D. But I don't think the typo is on your test. It is not, I just looked. Anyway, either way, the correct answer is 1.6%. The next problem we have here. A student desk is 55 centimeters long. A teacher desk is 75% longer than the student desk. How long is the teacher desk? Okay, so this is 75% longer. I know my original percent is always 100. Longer means it's bigger or greater, so that means plus 75. So that equals 100, whoops, 175%. So when I set up my proportion, I know my percent is always out of 100. In this case, it's 175. I know that my 175% is the new one. That's going to be the teacher desk. So the one that I know, or my original, is the student desk. So the 55 goes on the bottom. And I have X or N or whatever variable you want on top. And then I am going to cross multiply. So I'm going to have 100 times X, or 100X, equals 55 times 175. This is 100X equals, and get out those calculators, 55 times 175 is 9,625. I then divide both sides by 100. These cancel. I'm left at X equals 96.25. That is a weird looking 2. Let me fix that for you. 96.25. And look at that. There it is. It is choice number 3. Next, a racetrack is 2.5 miles long. A race car driver can complete each lap in 1/80th of an hour. What is the speed of the race car? Include the units of measure. The speed of the race car. Well, the speed, in this case, because they gave us miles and hours, would be miles per hour. So they tell us that the miles, in this case the racetrack is 2.5 miles long, per the number of hours, they give us 1/80th. So remember that ratio, or what appears to be a fraction, is of course a division problem. So that means 2.5 divided by 1/80th. I'm going to rewrite that. That is a 0. I'm going to rewrite that because I want my 2.5 to be an improper fraction as opposed to a mixed number. So 2 times 2 is 4, plus 1 is 5 halves, divided by 1/80th. Sing the math Macarena. Keep the first, flip the second, then you multiply. Keep the top with the top. 5 times 80 is 400. You should need a calculator to do that because 5 times 8 is 40. Throw that extra 0 on, that's 400 divided by, or over 2 times 1, which is 2. So I know I need to reduce that. 400 divided by 2 is 200. And in this case, including my unit of measure, it's miles per 1 hour, or the way that we typically just write that would be 200 miles per hour. Moving right along, today everything at a store is on sale. I love that. The store offers a 15% discount. The regular price of the sweater is $42. What is the discount price? Well, for these, I am going to kind of shift from that percent proportion to using my percent and switching it over to a decimal, because you've learned both ways. So let's make sure we utilize both ways while we're doing this. So everything in the store is on sale. It's a 15% discount. So my original object, or whatever it is that I'm purchasing, is always 100%. It's a 15% discount, so it means it's smaller by 15%. I know that 100 minus 15 is 85. So that means 85%. I'm going to change that to a decimal, which means I'm going to move the decimal 2 places to the left. Remember, the decimal, if we don't see it, is always like the period at the end of a sentence, and then it moves back 2 places. So that equals 0.85 or just 0.85, whatever you choose to write. Doesn't really matter. And then I'm going to be multiplying that times my 42. So I've got $42 times 0.85. Feel free to put that right in your calculator, and you should get the answer of 35.7. But this, of course, is money, so you should be writing it as such, so it should be $35.70. Okay, so we're still at this super awesome store. The regular price of an item is N dollars. What is the discount price in dollars? When I think about what I just did in my previous problem, I don't have to read, or the previous part of this problem, I don't have to redo that. I know everything is 15% off, so that means it's 85%. That 85% written as a decimal is 0.85. And everything is N dollars. I'm going to multiply that together. And this is my answer. I know this makes some of you uncomfortable when the answer looks like that, but that's what it is. Easy peasy. Here we go now. The discounted price of a belt is $16. What is the regular price? So if I simply use the expression that I wrote, and I know that I'm looking at the discounted price, I know that I got 0.85 n, because that's the expression, equals 16. Because remember, this is the discounted price. So now I'm simply going to solve that. I've got 85 hundredths, or 0.85 times n. The opposite of that is to divide by 85 hundredths. I do that on both sides because it's like a seesaw. I need to do the same thing on both sides. These two cancel. I'm left with n equals 16 divided by 0.85. Take out those calculators. You should get an answer of 18.823. Can't leave it like that, folks. It is a representation of money. So that means I need to round it to this place, which means I'm going to look at this number. That number is smaller than 5, which means I round down. So that means the 2 just stays as it is. So the answer is $18.83 was the original price. Our next problem. Sarah's uncle is paying for them to have dinner. The subtotal is $51.50. He has a 20% off coupon for the meal. And then after that discount, an 8.5% sales tax is applied. What does he pay for the dinner? Okay, so starting off, the subtotal is $51.50. He has a 20% off coupon. So our original is always 100. 20% off means minus 20. So that, of course, is 80%. 80%, if I move that decimal 2 places to the left, that equals 0.8. 0.8 as the decimal. I am simply going to multiply that times the subtotal, so 51.50 times 0.8. Use your handy dandy calculator. The answer you should get is 41.2. Of course, this is money, so I'm going to write it like that, $41.20. Okay, so that's not the final. After that discount, we have a 8.5% tax. So this is now my new original, So that's what I'm going to be using. My original is always 100%. And I'm applying or adding the 8.5% sales tax. So 100 plus 8.5 is 108.5%. To change that to a decimal, I need to move it 2 places to the left. So that is equal to 1.085 as a decimal. To do this, I am just going to multiply those two numbers together, meaning this number is now my new original. So I've got 41.20 or $41.20 times 1.085, and the final answer is I shouldn't have put that there yet. I got excited. It's $44 and the answer is 702. I round that to where the 0 is. Looking at the 2, that tells me it rounds down. So the final cost is $44.70. Of course, you know that's not the final. You need to leave a tip, but in this particular question, it doesn't ask us anything about that. Next, Amanda's brother works in a sports store. Amanda's brother earns a commission. He makes 3.2% of the amount he sells. Last week, he sold $900. How much was his commission? So the commission, we know, is always more, but it's not asking us for the total, it's simply asking us for his commission. So that means we're finding 3.2% of the amount of this. So I am, as a first step, going to take that 3.2%, change it into a decimal, which means I'm moving that decimal 2 places. So I'm going to need a placeholder here. So as a decimal, that's going to be 0.032. And then I'm going to simply multiply that times the 900. So I've got 900 times 0.032. And that gives me 28.8 or $28.80 for his commission. Next, the store bought a pair of skis for $390 and sold them for $455. What percent was the markup? So that means we're trying to find what percent this went up. So in order, first thing I need to do is figure out what the markup is. So that means I have to subtract 455 minus 390. I know you want a calculator for that, but it's really not necessary. I know from the 390 to 400, that's 10, and then there's another 55, so that's $65. Okay, so if I want to figure out what that $65, what percent of 100 that is, I'm going to set this up. I know that my percent is what I'm looking for. I know the $65 is the part. And the number on the bottom should be the original. So that would be 390. The thing we're missing is the percent. So I am going to cross multiply. So that's going to give me 390x equals 65 times 100. 390x equals 6,500 or 6,500. I then divide both sides by 390 because that's the opposite of multiplying. 390 on both sides. These cancel. I'm left with x equals 16.67, and this, don't forget, is a percent. Some of you still aren't labeling all of them correctly, so be careful of that. Our last problem, Amanda's brother earns $11 per hour. The store is offering him a raise, which is a 7% increase per hour. After the raise, how much will he make per hour? So our original is always 100. He's getting a 7% increase. That means it goes up 7. That equals 100. Whoa, what kind of craziness is that? 107%. Okay, so we know he's going to be making 107% of his original $11. So I'm going to change this to a decimal, moving it 2 places. That gives me 1.07. I simply need to multiply that times his original, which is $11, times 1.07, and that is going to equal 11.77, or $11.77.